What if the future wasn't something waiting for us, but something secretly rewriting the past? Not in a science fiction novel, not in a Hollywood time travel plot, but inside the cold equations of quantum mechanics themselves. Here's the shocker. Some of the most puzzling quantum experiments suggest that cause and effect might not flow the way we think. The arrow of time, forward, linear, irreversible, might bend. And in certain conditions, the effect could ripple backwards, shaping the very cause that supposedly created it. Retrocausality. That's the word physicists whisper when they test experiments like the delayed choice quantum eraser. Imagine firing a single photon through an apparatus. The moment it should decide its path, you intervene. Not before, but after it has traveled. The bizarre result? The photon seems to have known in advance what choice you would make later, and its past behavior lines up accordingly, as if the future reached back with invisible fingers and rewrote history in real time. This is not the neat clockwork universe we were promised in school. It's unnerving because if the past is malleable, then memory itself becomes questionable. Did things really happen the way we think? Or are we just standing inside a continuously rewritten timeline where the edits come not from some cosmic storyteller, but from the quantum rules beneath everything we see? And that's where this journey begins. Not with comfortable certainties, but with a dangerous question. What if causality itself is an illusion, and time is not a one-way street, but a strange loop where tomorrow already knows what we will do today? To understand how time could possibly run backwards at the quantum level, we need to step into the unsettling territory of quantum measurement. At its heart, quantum mechanics describes particles not as little billiard balls, but as waves of probabilities. A photon or an electron doesn't take one path. It explores all possible paths simultaneously. Only when we measure it does it seem to collapse into one definite history. But here's where the paradox begins. In John Wheeler's delayed choice experiment, a photon is sent through a setup that allows two possibilities. It can behave like a particle, taking one path, or like a wave, interfering with itself across both paths. Normally, the type of measurement you choose determines what you see. Wave or particle? Your choice sets the outcome. But Wheeler asked, what if we delay the measurement decision until after the photon has already passed the point of no return? Common sense says it should be too late. The photon's behavior should already be locked in. And yet, when physicists performed this test, reality bent. The photon's past behavior depended on a choice made later in time. It's as if the photon, moving through the experiment, somehow anticipated your future decision and retroactively adjusted what it had been all along. The past wasn't fixed. It was flexible, rewritten according to conditions that didn't even exist when the particle began its journey. Retrocausality takes this strangeness seriously. Instead of saying, the photon knew in advance, which sounds mystical, physicists propose that causation itself might not be one-directional. Just as a ripple on a pond spreads both forward and backward from the point of impact, quantum events could send influences not only downstream into the future, but upstream into the past. This does not mean you could send a message to your childhood self or undo a regretful choice. What it means is that, at the microscopic scale, the universe may not distinguish sharply between past and future. Instead of a rigid arrow of time, there's a web of correlations, and sometimes those correlations look as though tomorrow reshaped yesterday. But here's the deeper problem. If retrocausality is real, then our basic intuition about cause preceding effect collapses. How do we even define before and after if the two can be entangled? And if particles can edit their own history? What stops this effect from scaling upward, leaking into the macroscopic world we live in? Because if it does, time travel stops being fantasy and starts being physics. Our entire sense of reality is built on a simple rhythm. First this, then that. You press the light switch, then the bulb glows. You drop a glass, then it shatters. Causality isn't just physics. It's the mental glue that makes the world make sense. But quantum retrocausality rips that glue apart. To see how destabilizing this is, imagine a simple scenario. You're running a lab experiment, firing photons one by one through a setup. On Monday, you choose to record them in a way that reveals particle-like behavior. On Tuesday, you reconfigure the apparatus to reveal wave-like interference. When you go back to analyze Monday's data, you discover something disturbing. It seems to align perfectly with Tuesday's choice. It's as if Tuesday's decision reached back and influenced the photons that had already been recorded the day before. Now, of course, the data isn't literally changing inside your notebook. What's changing is the interpretation of what those photons were. The particles you thought had definite pasts suddenly appear to have been living in limbo until your later decision gave their past's shape. The illusion shattered. The past wasn't locked in. It was open, ambiguous, waiting. This is the essence of retrocausality. It's not about rewinding time like a videotape. It's about realizing that the categories of past and future might be less absolute than we assumed. The common sense arrow of time, one way, irreversible, untouchable, is replaced by a feedback loop, where what you do now can correlate with what was already true. Einstein hated this kind of reasoning. To him, physics had to describe a reality independent of our measurements. Yet the retrocausal view insists that the act of measurement doesn't just reveal reality, it helps construct it, extending influence both forward and backward in time. For Einstein, that was absurd. For modern physicists grappling with delayed choice results, it's a possibility they can't fully dismiss. Breaking the illusion of causality forces us into strange philosophical territory. If the past can be influenced by the future, then maybe past and future aren't fundamental at all. Maybe they're just convenient labels we slap on a deeper, timeless structure of reality, one where correlations stretch in both directions, weaving a fabric where time as we know it is only an emergent property. But if that's true, then one terrifying question lingers. If time doesn't truly flow forward, if it can bend, twist, or even reverse, then what exactly are we moving through? What is time itself? It's one thing to propose that time might not flow the way we think. It's another to back it up with evidence. Retrocausality isn't just a wild philosophical guess. It sits on a ladder of clues, each step stranger than the last. The first step is theoretical. If you look at the fundamental equations of physics, Maxwell's equations of electromagnetism, Schrödinger's equation in quantum mechanics, even Einstein's relativity, you notice something unsettling. They don't prefer a direction of time. The math works just as well backwards as forwards. Our experience of time flowing from past to future doesn't come from the equations themselves, but from how we interpret them. In other words, physics doesn't demand a forward arrow. We do. The second step is experimental. Wheeler's delayed choice experiment, and later its even bolder cousin, the quantum eraser, have shown repeatedly that the behavior of particles can depend on measurements made after they've already happened. These aren't fringe results. They've been tested and replicated with photons, electrons, even atoms. Each time, the data whispers the same disturbing message. The future can leave fingerprints on the past. The third step is technological. In recent years, physicists have been able to run quantum simulations and quantum computing experiments where retrocausal models actually simplify the math. Instead of assuming reality waits until measurement, some researchers describe quantum events as being influenced from both directions in time. Counterintuitively, this often makes calculations cleaner, as though the universe itself prefers a two-way flow of causality when running its code. And the fourth step is interpretative. Whole schools of quantum thought, from the transactional interpretation to two-time physics, embrace retrocausality head-on. The transactional view imagines particles sending handshakes of waves both forward and backward in time, locking in outcomes through agreements across temporal boundaries. Meanwhile, in two-time physics, reality is described not just by initial conditions, the past, but also by final conditions, the future, meaning both ends of time's arrow play equal roles in shaping the present moment. When you climb these four steps together, the ground beneath your feet starts to feel less solid. Retrocausality is no longer just a weird philosophical possibility. It begins to look like a genuine feature of the quantum world, one we've been forced to confront because the data won't let us ignore it. But here's the cliff. If the past can be influenced by the future, if tomorrow can rewrite yesterday, then we've stumbled onto a cosmic trapdoor.
Because the moment we admit this, we also admit something far more dangerous. What if our choices today are not truly ours, but echoes of decisions already shaped by futures we cannot see? If retrocausality is real, then the very foundations of how we understand human life start to shake. Because what is free will if the future can dictate the past? What is decision-making if causality isn't a straight line but a loop? Think about it.
We normally picture ourselves as agents moving forward through time, making choices that ripple outward. But if tomorrow can shape today, then your choices might not be original at all. They could be shadows of outcomes that have already been fixed, flowing backward into your present moment to sculpt the illusion of decision. Philosophically, this reopens a centuries-old battle between determinism and freedom. The retrocausal model suggests a strange hybrid. Events aren't strictly determined from the past alone, but also from the future. It's not a chain, but a web, one where your life is stretched between what has been and what will be. The terrifying possibility? That your sense of agency is just the experience of being trapped inside that web. But not everyone accepts this vision. Critics argue that retrocausality is an unnecessary complication. They point out that quantum mechanics can also be explained by interpretations like many worlds, where every possible outcome branches off without requiring time to run backward. To them, retrocausality feels like adding mystery where none is needed. Others argue that delayed choice results don't literally mean the past is rewritten. They just mean the past was never fully defined until measured. In that reading, retrocausality is more illusion than reality. Yet defenders fire back. Isn't that just shifting the problem? If the past was undefined until the future locked it in, how is that fundamentally different from the future influencing the past? At some point, words become masks, and we're still left with the same eerie symmetry. Time is not what we think. Some philosophers, instead of rejecting it, lean into the shock. They suggest that retrocausality might actually save quantum mechanics from deeper paradoxes. Instead of an incoherent universe that decides late, we have a consistent universe where past and future work together to shape reality. In this sense, retrocausality isn't a bug, it's the missing piece. But the cost of this solution is existential. If both ends of time constrain us, then where exactly is the space for spontaneity, for freedom, for creativity? Or, and here lies the real shock, maybe we've been asking the wrong question. Maybe free will isn't about escaping causality at all. Maybe it's about how consciousness experiences being woven into a loop of time that was never linear in the first place. And if that's true, then what we call the present isn't a moment moving forward, but a kind of meeting point, a handshake, between futures already waiting and pasts already shifting. If retrocausality isn't just a quantum curiosity but a real feature of nature, the future of science may look radically different from what we expect. Because if effects can flow backward in time, then every field that depends on prediction, from physics to computing to communication, is standing on the edge of reinvention. Start with quantum computing. Right now, the power of these machines comes from their ability to explore many possibilities simultaneously. But some researchers are beginning to toy with the idea that retrocausal frameworks could make algorithms even more efficient. Imagine a computation that doesn't just run forward, but is guided by its own future outcome, as if the correct answer were pulling the calculation toward itself. Instead of brute-forcing possibilities, the computer could lean on retrocausal structure to converge faster. It's speculative, but if proven, it would be nothing short of revolutionary. Then there's communication. At first glance, retrocausality looks like a golden ticket to send signals into the past, but most physicists think the rules of quantum mechanics prevent us from exploiting it that way. Still, even if we can't send a message to our younger self, the possibility of correlations across time could change cryptography and information security forever. Future-proof codes may not come from unbreakable locks, but from keys that exist simultaneously in the past and future. And what about cosmology? If both past and future shape reality, then the Big Bang itself might not have been a one-way launch into time, but the midpoint of a grand handshake, where the universe's birth and its distant death are entangled, each sculpting the other. That would mean the fate of the cosmos isn't just written from its beginning, but also from its end, with us living in the ripple zone between. But perhaps the most unsettling horizon is psychological. If our choices are echoes of futures we can't yet see, then the way humans think about responsibility, morality, even creativity might shift. Are we authors of our lives, or readers, catching up with pages written from both ends of the book at once? This is where the cliff grows darker. Because if retrocausality is true, then we have to confront a possibility far stranger than time travel, far stranger than paradoxes of free will. What if the future isn't waiting to be discovered at all, because it has already happened, and is quietly editing the present while we live it? So what does all of this mean for you, sitting here, listening right now? Retrocausality might sound like an abstract curiosity for physicists, but if the future can shape the past, then every moment of your life feels different. Because it means your story isn't just being written from behind you, it's being tugged from ahead as well. Think about the moments you've called intuition, those flashes when you make a choice without knowing why, and only later realize it was the right path. We usually explain that as subconscious pattern recognition, but what if, in some subtle way, it was the echo of a future outcome nudging you, rewriting the path that led you there? Retrocausality doesn't prove this, of course, but it cracks open the possibility. Suddenly, those mysterious hunches stop feeling like magic and start feeling like physics. It also reshapes regret. When you look back at a decision you wish you could change, retrocausality whispers something unsettling. Maybe that choice was never fully yours alone. Maybe it was shaped not only by your past, but by a future already waiting. Instead of imagining your life as a chain of mistakes, you could see it as a dialogue across time. Messy, confusing, but not random. And what about creativity? Artists, writers, scientists, all speak of ideas that arrive as if from nowhere, as if they were pulled from some well outside of time. If retrocausality is real, maybe that's more than metaphor. Maybe every act of creation is a handshake with futures already existing, reaching back to spark the present moment. This doesn't mean surrendering your agency, it means reframing it. You are not a puppet of the future, nor a victim of the past. You are the meeting point, the collision, where those two forces intertwine. The choices you make matter, because they're not isolated acts. They're the threads that tie together a fabric stretched in both directions. For some, this is liberating. The weight of "I could have done better" softens if the past was never fully locked. For others, it's haunting, the sense that their future is already written, whispering back into today. But whether comforting or terrifying, it changes the way you see your life. You stop walking as if time were a straight road and start realizing it might be more like standing inside a hall of mirrors, reflections bouncing from both ends, shaping the image you call now. And once you see that, you can't unsee it. So here we are standing at the edge of a paradox. We've seen how retrocausality rips apart our simple picture of time, how it hints that the future can whisper into the past, and how it unsettles our sense of choice, freedom, and even meaning. But the most important part isn't what it does to physics textbooks. It's what it does to us right now. Because if time is not a one-way street, then maybe our lives are not just forward marches, but intricate dances across a stage that already exists in full. You don't just move from yesterday into tomorrow. You are part of a dialogue between what has been and what is yet to come. The present is not a fleeting point on a line. It's a living bridge. Picture this: standing on a shoreline at dusk, watching waves roll in. You think each wave is only the result of distant winds and storms far behind. But what if the tide is also being pulled by the silent gravity of the moon ahead? Both forces, past winds and future pull, shape the water you stand in now. That's retrocausality, the realization that what you call now might always have been sculpted from both ends of time. And maybe that's not something to fear. Maybe it's a chance to see yourself differently, less as a traveler, more as a node in a vast conversation across time. A participant in a universe that refuses to obey our tidy arrows and insists on weaving a stranger, richer tapestry. So let me leave you with this. If retrocausality is true, if tomorrow can rewrite yesterday, then the deepest question is not about physics, but about perspective. Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.